networks can be used for more cases, but it's the main use case are images, and it computes the sum of the product of the elements. This helps extracting useful features like edges, textures, etc. That's the basic layer, but actually we can simplify that even more. Here, for example, you can see from regions of this image of a car, we can project them each region to one point, and we will get some other representation of this image. Originally, it had 3 layers, the 3 basic colors, and we can project this into many layers. We can choose how many we want. Then we will do pooling. It's just simplifying. One very common way of doing pooling is max pooling, which simply means that if you have 4 numbers in your square, you take the highest number, the maximum, and forget about the rest. So this way you take a square and you simplify it even into only one point, reducing complexity but keeping some important features. And then you repeat this. Commonly, the convolutions will more or less keep the shape of the input, of their input. The max pooling will make it smaller, commonly smaller but deeper, like you can see here. And then you repeat this process a few times, and then in the end it's common to add some multi-layer perceptron, for example, to get a good output. This multi-layer perceptron, it's commonly called fully connected layers in this case, but it's the same as multi-layer perceptron, but the input will be instead of a raw image or some clear thing, it will be the embeddings, the output of this layer of the convolutional neural network. And here we can see an example of a real architecture based on convolutional neural networks it won an important ImageNet competition some years ago, and it's still being used nowadays in so many applications. It's called VGG. It has many sizes. Here, for example, it's VGG 16. And as you can see here, it's an image of the original paper. We just have the image. Then there are some convolutions which keep it in the same shape. Then max pooling, which makes it smaller but at the same time deeper. Convolutions, which maintain the shape. Then max pooling, which makes it smaller and deeper, so on and so on. Then the information, instead of being really big but thin in space, not so fat, it becomes a very small image but very fat. And then after a final max pooling, we get that fat thin into a multi-layer perceptron, into some fully connected layers, and out of that you do image classification. And in this case, one of the classes will be a cat, and probably after all this process, the output will be that it's positive for the class cat. That's fast introduction about how convolutional neural network work. And as I said, it's a really great tool for image processing in general. Next, let's speak about recurrent neural networks and long short-term memory. Recurrent neural